Hey Geometry, this is Mr. Bloom, and this is section 4.5. And today what we're going to do is I can use and apply properties of isosceles triangles and equilateral triangles. Okay, so an isosceles triangle has two congruent sides. Okay, and I got a picture over to the left here. So when I'm talking about those isosceles triangles and those congruent sides, I'm talking about these are the sides that are congruent, the sides that are opposite the angles that are can be considered base angles. Okay, now these sides are the congruent sides of an isosceles triangle are its legs, the legs of the triangle. Now the third side of its base, so we're talking that this is the base side and these are the legs. Now the two congruent legs from the vertex angle, all right, so this is our vertex angle, that's right here, and that comes down, and the other two angles are the base angles, and those base angles are opposite the sides that are congruent. Okay, now when we're looking this over, I can move this sketch. I just got to move my board a little bit so I can bring up my going a little crazy. Whoa. Okay, now here we go. An isosceles triangle theorem. Okay, so this is where we're at. If two sides of a triangle are congruent, if two sides of a triangle are congruent, then the angles opposite those sides, okay, are also congruent. So that's this first one. So if I have AB congruent to CB, so if this, then angle A is congruent to angle B. So that's that first thing. The converse of this is also true. Now, the converse is a switch. So the converse is going to take this portion and put it last, and it's going to take this portion and put this first. So since that is true, our converse of if two sides of a triangle are congruent, then the angles opposite those sides are congruent becomes if two angles of a triangle are congruent, then the sides opposite those angles, those congruent angles, are also congruent. So that means, if I have a different picture here, if I have a triangle that has base angles congruent, then the sides opposite them are going to be congruent. Okay, and this is our vertex angle. This is also our vertex angle. So that's where that comes from. So let's look at this next thing and look at this proof. There's a proof of theorem 4.3, and that's the isosceles triangle theorem. So we begin with an isosceles triangle XYZ with segment XY congruent to segment XZ. So that's XY and XZ are given, congruent. So we're going to draw in this segment, okay, XB. It's going to be the bisector of the vertex angle. So that's the bisector. So I got this that bisects angle 1 and 2, so creating angle 1 and 2. And then I have XB congruent to itself because of reflexive. So now I have these statements with my given. I have XY is congruent to XZ, and XB bisects angle YXZ. That's our given. Now I just did our given on one line, so I'm going to go to our next step, reflexive property. And like I said, this segment, this red segment, XB is congruent to itself in that order, okay, because it's reflexive. Now, keeping in mind, we have our vocabulary word. We don't make up definitions. If I have a vocabulary word in the given, I use it in my proof. And we have definition of bisect, so I'm going to be talking about an angle bisector. And I know that angle 1 is congruent to angle 2 by definition of bisect. Now that I've got the angles congruent, I've got my reflexive, I have these two triangles, XYB and XZB, XYB and XZB, congruent because of side angle side. And that's out of side angle side congruence. Now, to talk about the fact that I have this isosceles triangle, and I have initially in an isosceles triangle, the legs are congruent. We're showing that angle Y and angle Z are congruent because of corresponding parts of congruent triangles are congruent. And that proves that isosceles triangle theorem works. Okay, we're just going to go on to the next page here. And we're going to look at isosceles triangles. So I know if this here is congruent, then the sides opposite are congruent. So consequently, I can set up a relationship that 11 is equal to x plus 4. Subtracting 4, 7 is equal to x. Okay, so that's number 10's done. And again, I look at the markings. I inspect the markings of my triangles. And my base angles are congruent. The sides opposite those base angles are congruent as well. So now I solve for x by dividing by 6, and I get 2 is equal to x. Okay, this one's here. Now, same idea here. Some of them are so nice because I have an isosceles triangle where base angles are congruent. X is equal to 13, and that's all I have to do. So once I'm able to recognize what type of triangle I'm working with, it becomes much easier for me to be able to solve some problems. Okay, I'm going to look at 13 here. And actually, you should look at 13, 14, and 15. Do those and then turn it back on and check your answer to make sure you get this, you understand it. So welcome back. I hope you turned it off and tried these. So I've got 7x plus 5 is equal to 19. That's my relationship because these are the sides that should be congruent. Now, 19 is equal to 7x plus 5. I subtract 5 and I get 7x is equal to 14. I divide by 7 and x is 2. So that's what we're supposed to find, the value of x. In my next one here, I am provided angle values. How do I know they're angles? Do you see those degree symbols? So I know they gave me angles, and since the sides are congruent, let me get a different color, the sides are congruent, the angles opposite those congruent sides are congruent as well. So 52 is equal to 5x plus 7. And I subtract 7 and I get 45 is equal to 5x. And I divide by 5 and 9 is x. In this last one, I know that these two sides are congruent. Therefore, the angles opposite those sides are congruent. But this is really confusing. But wait, if this is supposed to be congruent, that's got to be 3x because these two angles have to be the same. So I'm going to use triangle sum theorem and realize that 3x plus 3x plus 4x is equal to 180 degrees. Now I can add those up and say 10x is equal to 180 and x is 18. Now, how can we find this stuff and use this stuff? Well, there's a lot of things going on with this when I'm looking these things over. Okay, and you got to recognize what you're provided in the problem, and then we just use properties to find it. So this next one's a little tougher, but it's not impossible. Please notice that I have these sides are congruent. So therefore, the angles opposite those sides have to be the same. This must be 54 degrees. Also, I am provided these arcs, tick arcs. That means that this and this are the same. So really, if I really think about this triangle, I'm just going to pull it out here. I know that this is 2x, this is 54, and this is 54. Again, using triangle angle sum theorem, I know that 54 plus 54 plus 2x must be 180 degrees. So I got 108 plus 2x is 180. Subtracting 108, 2x is 72, and x is 36 after I divide. Now that's all we've got for isosceles triangle properties. We're going to look at equilateral triangles. Now, when I'm looking at equilateral triangles, I'm talking about this being equilateral sign. All sides are congruent. Okay? Now, knowing that all angles are congruent, all angles are congruent. So an equilateral triangle is also an equiangular triangle. So they all measure, because all of these sides or angles are the same, 3x is equal to 180, x must be 60. So they are all 60 degrees. So you will see me say that this is 60, this is 60, and this is 60 because all three of them are the same. Oops, sorry guys, I'm just flopping things up and down, and I just got to freeze this page. Lock in place. Now, if all sides are marked congruent, then all angles are congruent. In a similar idea, if all angles are marked congruent, then all sides are congruent. And that's true about our equilateral triangles. So we're going to use that in some problems coming up here. Let me freeze this in place. And we'll get this going. Right now, I have all the sides the same, okay? That means all these angles are the same. That means this is an equilateral triangle. The reason I pointed out all the angles are the same is that each angle is 60 degrees. So 2x plus 10 is equal to 60. And I can just solve that. 2x is equal to 50 after I subtract 10, and x is 25. Okay, so I'm using that shortcut to help me figure out my values. Now, the measures, when I read this, the measure of two of the sides of an equilateral triangle. So I've got an equilateral triangle, okay? Measure of two of the sides of an equilateral triangle are 3x plus 15 inches and 7x minus 5 inches. What's the measure of the third side in inches? Well, here's the thing. That third side is the same length as the other. Since these are all the same length, I can take this relationship and solve for x. Subtracting 3, I get 4x is equal to 15. Adding 5, 4x is equal to 20. Dividing by 4, x is 5. So now I know x is 5. This is not my answer. They want what is the measure of the third side. I've got to evaluate. So 7 times 5 minus 5 is equal to 30. And I'm going to double check. 3 times 5 plus 15 is also equal to 30. So what's the measure of the third side? Third side is 30 inches. Just like the other two sides, because an equilateral triangle, all the sides are the same. Now, I have an equilateral triangle, okay? I know that 4x plus 4x plus 4x, all these are the same because equilateral triangles, the angles are the same as well. They're all the same. Equilateral, angular. And basically that comes down to is that all the angles is 60. So I know that that is 60 degrees. So y plus 60 is equal to 180, and y is equal to 120 degrees. And if I solve and divide by 4, 15 is equal to x. In my next one here, I want you to think about this and try it. Turn me off and give it a try. All right, welcome back. So this is what we've got. I'm looking at several pieces of information here, okay? And in my pieces of information, I've got to figure out what's going on with what's happening here. So I have to pay attention to markings. This states that it's an equilateral, or excuse me, an isosceles triangle. It's not equilateral, it's isosceles, but it's an isosceles, right? Okay, so this is an isosceles right triangle. That means my base angles are the same and they share 90 degrees because this is 90 degrees and 180 minus 90 is 90 degrees left over. Because these two sides are the same, the base angles must also be the same. So I'm going to take the 90 degrees that's left over, divide it by 2, and find out that n is 45 degrees. Okay, now this n is 45 degrees, but so is this, and so is this. And the reason why I'm marking that is because it's going to help me find my next base angles for the isosceles triangle that we are looking at. This is an isosceles triangle. And now I know that angle M and angle M are the same. So I've got M plus 45 is equal to 180. I've got 2m plus 45 is equal to 180. Subtracting 45, I get 2m is equal to 135. Dividing by 2, I get m is 67.5 degrees. So that's what that is, and that is. I hope this made sense. And if it doesn't, you'll need to ask your local geometry teacher questions about the questions you have. Please make sure that you're taking care of that because your success is all about you and how you decide to make sure you complete your work. And as always, I'm Mr. Bloom and you're not. Have a great day, folks.